right, IM3 classes. Today is going to be much like yesterday's lesson, where we are going to be finding all the solutions for polynomials that are a little bit more, that are bigger, that have a higher degree. But this time we're going to have some complex solutions instead of just the real numbered solutions. So same stuff. We're going to use synthetic division to check answers, and then after we get that, we're going to this time we're going to complete the square to finish solving instead of factoring. Real quick, just a reminder: the number of solutions for a polynomial. All right, a polynomial has the same number of solutions, also known as roots or zeros, as its degree. Solutions can be real or imaginary. So this polynomial has 3 solutions because its highest degree is 3. This one has 6 because its highest degree is 6. And so this is where that multiplicity comes in that we talked about the last lesson. It might have the solutions for this one might be 1, 3, and 3. So it has 3 solutions, but we'd say it has a solution of 1 and then a solution of 3 with a multiplicity of 2. All right, let's do some practice here. We're going to be doing this later, where we need to state the possible rational roots for each equation. We're practicing this on the assignment today. The possible rational roots are just m over n. All right, so this value in front of the x is the m, this value over here is the m. All right, and it's factors, I should say, factors of these. So n, right here, I'm going to list it out. So m, factors of 13 would just be plus or minus 1, plus or minus 13. All right, and then n, there's a 1 there, so n is just going to be plus or minus 1. It's a weird way to put the 1. So m over n, just list out all the possibilities. So we can have 1 over 1, which is 1, so plus or minus 1. And then we can have 13 over 1, which is plus or minus 13. It gets a little bit more in depth when you have something other than 1 here. So let's look at this. So our m values can be the factors of 2 are plus or minus 1, and then plus or minus 2. And then the factors for n would be plus or minus 1 again, and then plus or minus 3. So our m over n, we can have 1 over 1, which would be plus or minus 1, or we could have 2 over 1, which would be plus or minus 2. Why do you keep doing that? Then we could have 1 over 3, which would be plus or minus 1 over 3, and then we could have 2 over 3, which would be plus or minus 2 over 3. So this has 4 possible rational solutions. In the next couple problems, we'll actually be using that. We'll check them using synthetic division, but just practice listing those out. All right, so next, let's do a root. We're going to start off where one root is given to us. So the root's given to us, so we have 1 solution. We want to find the other 2 solutions. It has a 3. We know there's going to be 2 solutions. So to do that, first thing you need to do is synthetic division. I'm going to divide this polynomial. Really, it's by x plus 3. But I'm going to use negative 3 on the outside. So it's going to be 1, negative 5, 175. First step is to bring down this 1. And then you multiply by negative 3. So 1 times negative 3 is negative 3. And then add negative 5 plus negative 3 is negative 8. Multiply by negative 3. You get positive 24. Negative 8 times negative 3 is positive 24. Add, you get 25. And then multiply by negative 3 one last time. And you get negative 75. That's 0. And that's good. That should work out. That's the remainder. So over here, I'm going to write out what the polynomial is that we're given. It's 1x squared minus 8x plus 25. If you wanted to, you could see if you could factor this. It's not going to factor this time. So what we need to do is complete the square, or that's how I'm going to do it. So since this doesn't factor, you complete the square or use quadratic formula. Since this is even right here, completing the square is going to be the easiest thing to do. So I'm going to subtract 25 from both sides. And I get x squared minus 8x is equal to negative 25. I need to find my c value. I'm going to do that up here. It's becoming a little bit of a mess to complete the square. So it's negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4 squared is 16. I'm going to add 16 to both sides. This side here, that factors to x plus or minus half this middle term. So half of 8 is 4. Since this is minus, it's going to be minus here, is equal to negative 25 plus 16 is negative 9. Oh, that's a weird subtraction. Square root both sides. From there, we get square root of x squared is x minus 4. Here, remember when it's a negative, all right, we can actually do this. So square root of 9 is 3, but since it's negative, it's going to be 3i. And then don't forget the plus or minus. And then last step, I am going to add 4 to both sides. And I get x is equal to 4 plus or minus 3i. We can't combine these. They're not like terms, so we just leave it like that. So our 3 solutions, x can be negative 3. That was given to us. 4 plus 3i or 4 minus 3i. So we have those 3 solutions. So just like yesterday, you're going to check to see if things factor, or actually they're not going to factor today. So check your solutions, and then whatever is left after you do the synthetic division, you're going to use completing the square or quadratic formula. Let's do another example here. We're going to skip to this one where we actually have to guess the roots. All right, so again, this is going to have 3 roots. So what I need to do is list out the possible roots. So n is just 1, so I just need to figure out the possible roots here is just going to be factors of 39. So things that divide 39. So it could be plus or minus 1, plus or minus 3, plus or minus 13, or plus or minus 39. So from here, what we need to do is guess. It's just a guess and check to test which of these roots is a solution to this. And we use synthetic division. And when we come up with a problem that does not have a remainder, then we have our solution. So 1, 1, 1, negative 39. Whew. So it should be pretty quick. I'm going to start with 1. So I'm going to check to see if 1's a solution. Bring that 1 times 1 is 1. Is 2 times 2 is 2. Is 3 times 1 is 3. You get negative 36. So not it. Has a remainder, so it does not work. We want this to be 0. So let's test another one. So 1, 1, 1, negative 39. This time I'm going to test 3. Probably going to have to go a little bit bigger. So bring down the 1. 1 times 3 is 3. 1 plus 3 is 4. Times 3 is 12. 1 plus 12 is 13. Times 3 is 39. And we get 0. Perfect. Didn't have to check too many of them. I like when that happens. So this works out because it's 0. All right. So I know one of my solutions is 3 now. I need to find the other 2. What I'm going to do is solve the resulting polynomial here. So the polynomial is x squared plus 4x plus 13 is equal to 0. Since this is even and there's no coefficient there, I'm going to use quadratic, or not quadratic, I'm going to use completing the square to solve this one. All right, so to complete the square, first thing I'm going to do is subtract 13 from both sides. So I get x squared plus 4x, that's 0. 0 minus 13 is negative 13. So we get, I'm going to find the c value to complete the square. So c is equal to 4 divided by 2 squared. 4 divided by 2 is 2. Squared is 4. So I'm going to add 4 to both sides. Oh, that's not fun. This is going to end up being close to the same answer we got last time. This is going to be negative 9. This is going to factor into x plus 2 squared. Make this a little bit bigger. All right. So just a real quick reminder, it factors like this. So because we completed the square, we have a perfect square. It's going to always factor into half the middle term. So half of 4 is 2. Since this is plus, this is plus. Solve this, I need to take the square root of both sides. And I get x plus 2 is equal to, square root of negative 9 is going to be plus or minus 3i. And then last step, subtract 2 from both sides. So my solution to that polynomial is going to be negative 2 plus or minus 3i. So my 3 solutions, just as a reminder, we found 3, and then it's negative 2 plus 3i, negative 2 minus 3i, the 3 solutions. Let's do one more problem. See if we get one that's not an imaginary solution, but irrational. All right, so first thing I need to do is determine the roots. So since this is 1, this is going to be quick. It's just going to be factors of the last term, the constant term, which is 45. So I'm just going to do what factors 45 is, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 9, almost forgot 9, plus or minus 45. So those are the numbers that go into 45. I may be forgetting one, but I think this is going to be enough for us to do what we need to do. So just start checking with 1. So 1, negative 11, 9, 45. So bring down the 1. 1 times 1 is 1. Add negative 11 plus 1 is negative 10. Negative 10 times 1 is negative 10. Add, you get negative 1 times negative 1 is negative 1. So I get 44. Since this is not 0 here, this does not work. Let's move on to a bigger number. So we're going to do 3. So 1, negative 11, 9, 45. So 1 times 3 is 3. So negative 11 plus 3 is negative 8. Times 3 is negative 24. Plus 9 is negative 15. Times 3 is negative 45. Add, we get 0. Awesome. Here is our solution. All right. So we're going to finish solving this. So the resulting polynomial is 1x squared. I don't need the 1 on there. Minus 8x minus 15 is equal to 0. Again, I'm going to solve by completing the square. It's going to be the fastest way to do it. So I'm going to add 15 to both sides. So you get x squared minus 8x is equal to 15. Cancels out over here. So we get C is equal to -8 over 2 squared. -8 over 2 is -4 squared is +16. So add 16 to both sides. 15 plus 16 is 31. Almost put 21. 31. Factor that. It's going to be half of the middle term. So that's going to be half of 8 is 4. Since this is minus, this is minus. Square root both sides to solve. 31 is not a perfect square. So we just leave it as plus or minus the square root of 31. So you get x minus 4. And then last step, I'm going to add 4 to both sides. So I get x is equal to 4 plus or minus square root of 31. So again, our three solutions are, we found 3 by guessing and checking. And then we have 4 plus the root 31. And then the last one is 4 minus root 31. So those are our 3 solutions. All right, that is it for now. See you guys next time.